Hello, my friends, and welcome back. It has been a minute. Things are looking a little bit different. The first thing you'll probably notice is that I am making this video on a Mac, and that is because I purchased a Mac Mini at the beginning of the summer. You might be wondering, why did I, the developer of Komorebi, the tiling window manager for Windows, purchase a Mac Mini? Well, it's actually because I wanted to record some music. I wanted to record an album, and the software that I've always been most familiar with is Logic Pro. And I thought, you know what, I'm just gonna bite the bullet. I don't want to learn how to use a whole new digital audio workstation. I'll just go with what I already know how to use so that I can just focus on composing and recording music. And that worked out really well. That record has been mixed, it has been mastered. We're just waiting on album art and artist photos. I think that will be on like Apple Music, Spotify, everywhere within 2 months. So I'm really excited about that. When I bought the Mac Mini, I told myself I will not work on anything programming related on the Mac Mini until the record is finished. So now the record is finished and I can work on stuff. I can work on programming stuff. And yeah, the first thing has to be a tiling window manager. So we've been talking for a while about this idea of a cross-platform tiling window manager where you can basically have a portable configuration and predictable behavior across different operating systems. This is something that I really want. So if I have had to use macOS and MacBook for work in like the last 5 years since I started writing Komorebi, I've always defaulted to using Yabai. But during that time, I didn't have my own Mac Apple hardware, so I didn't really put any time into this idea of Komorebi for Mac. But now that I have my own hardware, I'm like, you know what, let's give it a try. And this time I wanted to make videos showing my progress so that people can follow and learn along the way. When I began working on Komorebi for Windows, I knew absolutely nothing about developing for Windows. I knew absolutely nothing about creating a tiling window manager. I learned everything as I went along, and it was a really fun experience. Unfortunately, at that time, I didn't have a YouTube channel. I wasn't making videos, and so I didn't really get to share that initial learning curve with people. I started making videos on YouTube well after Komorebi was established as a piece of software that was used by thousands of people. Now by like tens, hundreds of thousands of people. I don't know, by a lot of people now. But now, like, you know, I have the YouTube channel, I have the audience. I figured we are once again starting from zero. I know absolutely nothing about developing for macOS. So I'm just gonna share how I break down quite a big, complex task. And that task is creating the tiling window manager, and how I approach working on and building for a system that I'm not really familiar with. So I have a project here that we can turn our attention to. It's a playground project at this point. And I got a bunch of stuff. And we're gonna walk through it. So the first thing that I figured out was that to do anything related to what I want to do, there are a bunch of like permissions that need to be granted to whatever process. So if you want to be able to read the titles of windows, you need to have the screen capture access granted. And if you want to use the accessibility API, your process has to be trusted by accessibility. It's a little bit weird, right? So here we have CG pre-flight screen capture access, and we don't have documentation here. I guess I can describe. So this returns a Boolean, and it's a pre-flight check, right? So it checks if you have that access. If we don't have that access, there's this very handy function, CG request screen capture access, which will bring up a modal that will say, hey, do you want to give this process access? Click here and then enter your password. It goes through the system settings. If that fails, right now I'm just exiting out. And then the next thing is checking if the process is trusted in accessibility for the accessibility APIs. You can do a check, but you can't spawn a modal for this. So it's not great. I'll have to think about that. But this is the first stuff that you need to do. And CG is a prefix that is related to the core graphics macOS API. So everything that starts with CG, at least in my mental model right now, I know that's related to the macOS core graphics API. And AX is the accessibility API, which I think technically comes under application services. At least that's where I'm using it from. So in my main function, I check permissions. First thing I do. We can't do anything if we don't have the right permissions. And so where do we start with a tiling window manager? I thought back to how I started when I was developing Komorebi for Windows. I remember the first thing that I figured out how to do was step 1, list all windows on the screen. That was the first thing that I did. And so I went looking around and I saw once again in core graphics, there's this function called window list copy window info. I wonder, can we get up the docs for this? So generates and returns information about the selected windows in the current user session. There are some options that you can give. They're not particularly useful in my opinion. At least not for what we're doing. So I can give this option to show only windows that are on the screen and to exclude desktop elements. But with this, I'm still getting a whole bunch of invisible windows. We're gonna come to that. But this is step 1. I get a list of windows. So why don't we annotate these? Step 1, we get a list of windows on the screen. Also, we need the display size for stuff later on, so we get that again from the core graphics system API. Bounds is in the macOS world, bounds is used for things that are measured in pixels. And I know there was another one called display screen size, and this returned the size in millimeters. So that was a little bit confusing for me initially, but in my mental model now, whenever we talk about bounds, we're talking about measuring in pixels. Okay, step 1, we have all of the windows. What is the next thing that I want to be able to do? I want to be able to filter just the windows I care about. And so this is basically, I don't want any invisible windows, so no invisible windows. So I get this list. I make a vec that I want to collect valid windows into. And then once I have the information, I'm going to come back to all of this. There's like a whole... Maybe I'll come back to it in a different video. But changing from different data types and like dictionaries in Objective-C, I am not a fan. I am not a fan at all. But we get the info. We get some window info. And what does window info look like? So name is what is used to refer to a window title. We have an owner process ID, an owner name, and owners are the application. So the owner of this window is Rust Rover. Alpha, I'm assuming, is like transparency, and bounds is like the size in pixels, so the top, left, right, bottom coordinates. So we get our window info from this list, and we get that. We want to know, is this a valid window? So I have this function called validated that I can call on window info, and it returns an option of valid window info. And the only real difference here is that the option string is like a mandatory string. So what are we doing here? We're making sure that we have a window title, and we're making sure that we have a window alpha. So we want to make sure that the alpha is not 0.0 because that is invisible. We're making sure that the height is not 0.0 because if the height is 0.0, it's invisible. And yeah, that's working pretty well for me so far. That's like the minimum amount of work that I can do to just get a list of windows that are like actually valid windows that I want to tile so that we don't end up with ghost tiles. So that is step 2. Let's add that annotation here. And then once I have a list of those, I can collect them here. And there are a few steps in between. So step 3, collect valid windows. And so these 3 steps are all related to just getting a list of windows on the screen, essentially. You get the list, you refine the list, and then you separate the useful stuff from the useless stuff. Next up, when I started Komorebi for Windows, after I got a list of windows, the next thing I wanted to do was to be able to place them at specific coordinates at specific sizes on the screen. And so in order to do that, I needed to know what is my display size. So step 4. And this is, I don't know how big it is, because in macOS, like, it changes depending on your scaling. But it's an ultra-wide monitor, let's say. So step 4, get the display size. And then based on the display size, after doing some layout calculation, this comes actually a little bit later. I'm going to save this as a later step. You know what? This will be a later step. After you have a list of windows, you want to be able to place them anywhere. Like, you can give like hard-coded coordinates, and that's actually what I did here as well. So step 4, place the windows in arbitrary positions. And so I have this nice little window.setPosition method. Took me a while to figure out. So let's jump into this. So set position, it calls set point and set size. So set point is setting the left and the top, and set size is setting the right and the bottom. So we'll look in one of these. This is pretty gnarly. This is pretty freaking gnarly. everything in the Objective-C2 libraries is like a wrapper around the C, Objective-C, Swift, like whatever. I think at the end of the day, it's all just C. It's C all the way down to like the C SDK for macOS, like the various SDKs, which means you got to pass around pointers and you got to pass around callbacks and just like that old school Win32 style of programming. So I'm familiar with it. I'm familiar with doing it in Rust. But one of the differences that I see is that there is a lot of use of non-null, which is like a wrapper type around raw pointers. I'm getting familiar with it. Yeah. So with setPoint, you give it a point, which has an X and a Y. So this is going to be your top and your left. Then you cast that into like a non-null C void pointer. Then you make an accessibility value. So like we already know that this is CG point, but we have changed the type to a non-null pointer to C void. Then we make a value from that pointer and we say, hey, this value is a CG point. Like the thing at this pointer, it's a CG point. And that's what the accessibility value is wrapping. And then we're calling on window, we're calling self.element set attribute value. And so there's this thing called the position attribute, accessibility position. And then we're setting the value, which is whatever our X and Y, our top and left are. Pretty confusing. Honestly, pretty confusing. And what the hell is an element? What the hell is an element? So, our window has an element and an application. This is quite different from the way things work in the Win32 API. Because once you get a list of windows, you can directly manipulate that window using its window handle, right? But in the macOS Accessibility API, every window is associated with an application. And from what I can tell, you're pretty much going to have to track a reference to that application with each window. So an application also contains an element. And like they're all these accessibility UI elements, that's how they're modeled. So let's go back up to our main. And here, after we get the validated window information, it's like the window information does not return a handle to the window. It's just like a description of like stuff related to the window. One of the things that we get from that validated info is the process ID of the owning application, right? So each window belongs to an application. Each application has a process ID. And we can use that to create an application. This is like a wrapper struct that I have. And what we're doing in the constructor is we're saying, okay, to get this element, we can call this function method on accessibility UI element, new application, which returns the top level accessibility object for the application with the specified process ID. And because I think you lose access to this after you pass it, because this is just like a UI element and like layers of abstraction I don't fully understand, but I haven't found a way to get the process ID back after you create the accessibility UI element, so I'm also storing the process ID for later. So that's what we are doing here. We're making a new application, and then an application can have many windows, right? You can have multiple projects open in Rust Rover in multiple windows. So you want to make sure that whatever window you're going to be operating on is like the window that you got the info for, right? You can't just take the first, because how do you know that the first is going to be the one? So let me it's a reference project that I've been looking at, another tiling window manager in Rust for macOS. So I have two windows open, and so if I have the application Rust rover and I have two Rust rover windows, like how do you know which application window you're going to be operating on? So we get the window by the title, and this is another little wrapper that I implemented. So we have a target, which is none to start with. This returns an option, because what if you don't find the window by title, right? So you're going to return a none. And then we look at all of the window elements on the application. We'll take a look at this. We construct a window using the element and a reference to the application. And then we get the title for that window. And if the window title is equivalent, we set our target. And if that iterator here never returns something with a matching title, then we'll return none, right? Like something is amiss and we need to investigate, essentially. So window elements. Ooh, this one ain't fun. So window elements. So if you have an application, you can get, if you have an application as an accessibility UI element, you can copy attributes and values from like the lookup dictionary somewhere in the system related to that element. So for the application element, we want to look up accessibility windows, which will return a list of window elements. And we want to store that in like this pointer to something. So I think standard pointer null, this function is equivalent to 0 initializing the pointer. So like assume init. And that's why you can pass it to non-null. And so we pass like this mutable, this pointer to some mutable section of memory. Is that how it is? We pass something where we want to write this value to, right? We have application windows, and then we call that, and it will mutate that value with whatever was found for this attribute, whatever data was found. Then we try to cast that pointer to a core foundation, CF stands for core foundation, array of accessibility UI elements. But we know that this is like a window accessibility UI element and not an application UI element. So we cast moot because I think that non-null requires a mutable pointer to the type. Yeah. And we need a non-null because CF retained requires a non-null pointer. I'm sure I'll understand more of this as I go on. And you can see already there are exceptions for different applications. So if it ends up being the case that this cannot be initialized because the pointer is still null, then we'll return none. Otherwise, we'll return the core foundation array, which is a pain in the butt to work with. I wish we could just return plain old Rust vex. Maybe I'll figure that out at some point, but I haven't figured it out now. So anyway, at the end of this, you get a bunch of AXUI elements, which are window AXUI elements. And that's where we construct the window from. So you see window also has this AXUI element. And then we look up the window title. So title is something that I've implemented as a wrapper. And you can see again the same pattern. We have this assume init null pointer. We copy an attribute value again for the window element, right? So it's still an AXUI element, but it's a window element. If you try to do this on an application element, you would get this error. The attribute is not supported by the AXUI element wrap, right? Because you are not allowed to not allowed to, or just like it doesn't exist. Like an application doesn't have an accessibility title, a window has an accessibility title. So I say I want to get the title for the window element. I pass in this mutable pointer to title. I'm saying write that value, copy that value into wherever this memory is. And then we create another non-null because we need non-null for CF retained. And we're casting that to a core foundation string. Again, I've figured out some weird edge cases already, so this is always going to be none for Finder windows. So we can skip over this element ref, right? Because this is being called in a loop, right? So for element and window elements, so we can just skip over this. We can return none. Otherwise, if we have a core foundation string, we'll get CF retained, which is a reference counted pointer type for core foundation types. It's doing reference counting, so we don't have to worry so much about the memory. And then we have a toString implementation on CF retained of CF string, which means that we can have like a Rust memory managed string to return. And so, yeah, at that point, we are able to get the window by title. Cool. So we have our windows. We have our windows as a struct window with an element. And we can see how when we're setting the point and we're setting the size, how we are using this pattern. So we have the copy attribute value on an element when we want to read something. We have the set attribute value when we want to make an update, when we want to write something. So we're writing new attributes for each window. We're saying this is going to be the top left, this is going to be the bottom right for the size. And, you know, it's going to do its thing. It's going to do its thing. So I copied over from Komorebi like a really simplified version of the recursive Fibonacci BSP layout. Added in a rect wrapper that's similar to the one we're using in Komorebi for Windows. Added some conversions for CG size and CG rect. And so here, once we have our valid windows populated, then we are gonna step 5, we're gonna calculate layouts. Actually, that's step 6, I guess, because like step 5 is gonna be we need to calculate layouts relative to the display size. Get the display size in pixels, and then step 6, use the display size in pixels to generate a layout. And if you're not familiar with how this works in Komorebi, one of the realizations that I came to very early on is that when you're generating layouts, they should be in my opinion, they should be completely independent from the application windows, right? So you should just, in my opinion, you should just be generating rects and then applying those rects to any window, to any application. I don't think it makes so much sense to have that so tightly coupled to a specific window or a specific application. So we use the display size in pixels to generate a layout, which is a bunch of rects. And the way this works is that each rect in this vec is going to be at the same index of each window. And so you can like zip this, zips up two iterators into a single pair of iterators, so it will return windows at index 0 and layouts at index 0 here, and then it'll do at index 1, 2, 3, up until the final elements of both. So once we have that iterator, we're going to place the windows in arbitrary, I guess they're still arbitrary positions. And that's like a really basic, minimal working tiling window manager, in my opinion. So I'm going to do a little cargo run. I really hope this works. And there we go. We have like our little BSP. It's, you know, it's a little rough around the edges. We need to account for like padding. We can see that down here in the bottom right, this needs to account for the dock. But like more or less, it's working. It's like, it's a one-shot thing. It runs, it sets all of the positions, and then it exits. And like this could even be like, you could just like spin this off into its own program that you call it a hotkey. It's like if you're someone who likes to just like mess around like this, and then you're like, oh, I just want a quick view, then you could hit this, and then maybe you also save the previous state, and then you go back to your messy state. I don't know, like, is this already in and of itself is really cool, is what I'm trying to say. Like, you don't have to have the most complex version of something for it to be useful. You know, like, just get used to breaking work into minimally useful chunks and making progress like that. Because if you're always thinking like, oh, it needs to have everything, it needs to be perfect, like, it's a really easy way to get burnt out and bogged down. Bro, what is wrong with... Yeah, it's really hard for me to drag the Zen browser on macOS. I don't know why. Okay, so that was one thing I wanted to show. The next thing is I want to show the focusing. So we have two windows, right? In Rust Rover, we have one which is this playground project, one which is the panel repository for the panel tiling window manager. And I want to make sure that when we are focusing, we focus the correct window. So I added this little bit in window. Oh, okay. I need to make a little change. So if let's window title equals window.title, because this is now an option. If window title contains a panel, then we're gonna call running focus for the panel Rust Rover window. And actually I'm gonna turn off setting the positions. And so this is kind of like the next step. Like once you have everything organized in accordance with a generated layout, the next thing that you're going to want to do is be able to change focus in a direction. And you want to make sure you're focusing the right window. In the Win32 API, this is not necessarily an issue because we don't have this extra layer of abstraction where you have to track the application for every window. Like you can just say, focus this window, and it's going to work. But that's not how focus works here. it's again like this two-part process. So if we take a look into the focus function that I implemented for window, we are doing two things. So we're wrapping this in, and I don't know what NS stands for. What does NS stand for? I'm sorry, I don't know what NS stands for. Into an NS running application, which takes the process identifier that we saved earlier on the application struct. And then we activate it with options. So activating it is like you're bringing that application to the front. But that in and of itself is not enough, because an application has multiple windows. So you're not in the Win32 API, like you're focusing and you're raising the window, which is something that has a handle that is independent of the application. Here, what you're doing in macOS is you're activating an application. An application can have multiple windows. So then we want to activate. Oh man, I might have gotten this wrong, but it worked. Okay. But so then after that oh wait, no. So this self.element is the window element. And then we're saying we want to set this attribute, accessibility main, which is saying make this window element the main window element of this application. So in the case of Rust Rover, we have multiple windows. When we call focus, we are going to be calling focus on the panel window. And it is going to make the panel window the main window, and so that will be focused. And so what I'm going to do is I'm going to put this at the absolute bottom of the Z order. So we have panel at the bottom, then I'm putting Zen there, I'm putting Discord, and then I'm putting this one on top. And so now when I run this code, we're not going to set the positions, but we are going to go through, and when it reaches the panel window, it's going to call focus. And what we should end up with is this window being focused above all of the others. And there you have it. It got brought to the front. Says running focused for the panel Rust Rover window. Wow, that was a lot. Damn, I got a lot done. I got a lot done. It's like I feel like I'm in a groove now. And I hope this is enjoyable to watch. It's really enjoyable for me to work on this. It's been a long time since I worked on something that I enjoyed. I do enjoy working on Komorebi for Windows. I still enjoy working on it, but there's like a lot of pressure, just because it's something so widely used now, and it's in some ways synonymous with tiling window managers on Windows. So this one I will be just like developing for myself for fun, privately for a while. I really like the way that Ghosty was developed, Ghosty by Mitchell Hashimoto, it was mainly developed in private for a while, and he gave some status updates and blog posts, and then he invited collaborators, and it was like, I saw that and I was like, hey, that seems really cool, like a really nice way of leading a project, right? Like a project that lives or dies based on one person, which is pretty much what Komorebi is at this point. So yeah, maybe I'll do something like that eventually when it is ready. It's going to be the same deal as Komorebi for Windows. You'll have it released for personal use under the Komorebi educational source license. It'll be dual license with an individual commercial use license for commercial use. But yeah, that's still quite a ways away yet. You might have noticed we don't really have any window management state tracking implemented yet. We don't have any event hooks, so like there's still a lot to do, but I'm having fun. I am having fun doing this, and I hope that you will have fun watching this. I hope that you'll learn. I hope this will inspire you to tackle a big project that you might have had in mind, by splitting it into smaller chunks. Yeah, man, I'm out of practice. That's pretty much it. If you want to come hang out, we have a Discord. The link is somewhere here. There's a Discord server. Subscribe to the YouTube channel, of course. If you want to use Komorebi for Windows, if you want to use it at work, you can head on over to the individual commercial licensing page, find out more about that. We have a whole bunch of user testimonials about how Komorebi is great. Check out those as well. I hope to make something equally useful for people using macOS. That is it for today, my friends. It is nice to be back. I hope that whatever you all do today, you have a great day. Free Palestine, and I'll see you all back here next time.